Happy New Year, everybody, and welcome back. I hope many of you weren't waiting patiently for these last two videos to come out. But I'm breaking up 3.6 into two different sections, one for simple rational functions and their transformations, and then two ones that are a little bit trickier and ones that we'll have to work with a little bit more in. So the first ones that we're going to deal with are all a matter of looking at this parent function, which is f of x equals 1 over x. And as soon as I get my pen here. And so when I look at f of x equals 1 over x, this scares some people because it's division, and people don't like division or they don't like fractions, and it looks like a fraction because it is. And so we're going to try and make sure that you don't worry about that. But we're going to start off by thinking about what points would be on this graph. So first one, if we go from -3 to 3 by ones, we say 1 over -3. Well, that's easy. That's -1/3. It'd be easier to type this in. And then 1 over -2 would be -1/2. And then 1 over -1 would be -1. 1 over 0, that's one of our domain rules. That's actually undefined. And so we're going to say, well, it doesn't work there. And then 1 over 1 would be 1, 1 over 2 would be 1/2, and 1 over 3 would be 1/3. Now, if I plot these points on the graph, I can come over here. We don't have anything at 0 because it's undefined, but at 1, we have 1. At 2, we have 1/2. At 3, we have 1/3. And if I really wanted to go a little bit further, I could say at 4, we have 1/4. Likewise, at -1, we have -1. At -2, we have -1/2. At -3, we have -1/3. And at -4, we would have -1/4. So these points kind of give us a little crazy graph here. And it's like, well, what happens from here to here? We can see that as x increases, this graph keeps going down, and that's probably going to make sense because if you think you're going to put bigger numbers on the bottom, you're going to have 1 divided by bigger and bigger numbers, it's going to get smaller and smaller. Maybe it'll get to 0, maybe not, we don't know. And then likewise over here, if we do negatives, 1 over a negative really big number, it gets closer and closer to 0, but it's still negative. Will it ever get to 0? We'll talk about that in a minute. What really we want to know is what happens between here at -1 and here at +1. Does it just go straight to it? Does it keep going in this curve? Does it cross or zigzag, or what happens? And so that's our next guess. In order to analyze this a little bit more, we're going to go ahead and look at some fractions between -1 and 1. You can see right here at -1, it's -1. When I plug in -1/2, I have 1 divided by -1/2. And when you divide by a fraction, you actually multiply by the reciprocal. So it's 1 times -2 over 1, which is just -2. And so that's pretty cool. So right here I get -2. And if I put 1 over -1/3, I get -3. And if I put 1 over -1/4, I get -4, and so on and so on. 0 is still going to be undefined. Here we're going to get 3 and 2 when I plug in 1/3 and 1/2. So if I add these points, here's -1/2, -2, -1/3, -3, and if I wanted to keep going, -1/4, -4. On the other side, I have 1/4, 4, 1/3, 3, and 1/2, 2. And so you can see what happens here as these graphs get closer and closer to 0, they increase without bound. These are all nice terminology words that we're going to talk about here in a second. Now, what happens at x equals 0? It's undefined, and what we look at is, what is this called? Well, this is actually called an asymptote, and I'll type that in there, but we draw it in on a graph with a dashed line. And an asymptote is really a line that the graph gets closer and closer to as our x values get closer and closer to that asymptote. Or if it's a horizontal asymptote, then it gets the y values get closer and closer to it as x gets further and further out. As we look over here, this is our graph that we were just looking at, and you can see that there's some terminology here. It says, for example, f of x, let me get my red pen here, f of x goes to infinity as x goes to 0 plus. And this plus means it approaches from the right. So as I approach x from the right, this graph keeps getting bigger and bigger and bigger, and the y values keep getting larger and larger, or going to infinity. Down here, likewise, if you look, f of x goes to negative infinity as x goes to negative, or goes to 0 from the left. You can see that as we get closer and closer to 0, these numbers are going to get more and more negative, or larger negative numbers going towards negative infinity. We can also see that as f of x goes to 0, as x goes to infinity, that's meaning as my x values get larger and larger and larger, my y values get smaller, but they're never going to get to 0. And that's because if I'm always doing 1 divided by something, this big, big number, if I had one pizza and I split it up amongst everybody in the world, like 6 or 7 billion people, everybody's going to get something. It may be just a small crumb or half of a crumb, but somebody's going to get something. And so if we take one thing and we divide it up amongst a large number of people or a large number of things, then it's still going to be something. It may be just a molecule of pizza, but that's all it will be. Likewise here, if we go as x goes to negative infinity, f of x is still going to go to 0, and that's, again, the same case, it's just in the negative direction. Up here are some meanings. We talked about this here as x goes to a from the left, as x approaches a from the right. This is as x goes to negative infinity or positive infinity. So this graph actually has two asymptotes. It has a vertical asymptote at x equals 0 right here, and it has a horizontal asymptote right here at y equals 0. And you can see the definitions here. It says the line x equals a is a vertical asymptote of the function y equals f of x if y approaches plus or minus infinity as x approaches a from the left or the right. And so you can see here are a couple different examples. And then down here, the line y equals b is a horizontal asymptote of the function y equals f of x if y approaches b as x approaches positive or negative infinity. And we'll take a look at these as we move along through our graphs. Now, we know where the parent function is, and I'm going to just draw this in black here. We know it goes 1, 1, 1/2, 2, 1/3, 3, 1/4, 4, 2, 1/2, 3, 1/3, 4, 1/4, and so on and so forth. So this is our parent function. I'm trying to draw it in nicely. One branch of the parent function. These are both called branches. 1/3, 1/4, 1/2, 1/3, 1/4. And we have those asymptotes there as well. I'm not going to draw them in just to keep the clutter down. And when I look at this graph, I see 1 over x minus 2 plus 1. Well, this is replacing x with x minus 2. And what that means with all our other transformations is that it's going to move the graph right 2 units. And this plus 1 is going to move the graph up 1 unit. And so what that does is it changes where our asymptotes are. Our asymptote was at x equals 0. Now it's going to be at x equals 2. And so I'm just going to draw a nice dotted line there. And it was at y equals 0 was our horizontal asymptote. And now it's going to be at y equals 1. All the other points, they're going to move in the same fashion. And so this is going to be our new r of x, which is 1 over x minus 2 plus 1. You can see I'm just moving these points right 2 and up 1. This next graph, s of x, is 2 times x plus 1. And we can rewrite this as 2 times 1 over x plus 1. Now, the 2 is actually going to be a vertical stretch because it's outside the function. It's a vertical stretch of 2. And this x plus 1 is going to be left 1. And so again, I can go ahead and move my vertical asymptote so that it's right there, x equals -1. And then it's going to stretch. So instead of being at like 1, 1, it's going to be at 1, 2. And instead of being at 2, 1/2, it would be right here at 2, 1. And so it's going to be just a little bit wider as we go out. The horizontal asymptote for this one does not change at all because, well, there's no vertical shifts. It's just a horizontal shift. And then one last one is something like this. And here we can't easily take a number out. Here it's not easy to see what the transformations are. So what we should do with this one is we should do division. Now I'm going to do long division. You could also do synthetic division, I guess, if you wanted to. 3x minus 4 goes into, or divided by x minus 1. And we say what times x is 3x, and that's a 3. So I multiply down 3x minus 3. Change my signs and add, and I get -1 as my reciprocal. So I get -1 over x minus 1. Now you might say, well, that doesn't help us a whole lot, but it actually does. Because if I rewrite it as -1 over x minus 1 plus 3, you can see right here, this is a negative, so that reflects over the x-axis. And then the -1, x minus 1, moves it right 1. And then the plus 3 moves it up 3. So my asymptotes are going to be at x equals 1, y equals 3. Now instead of having a branch here and here, we're going to have the branches up here like in the second and the fourth quadrants, and you can see how my sketches are getting a little bit sloppier, but you can look at the graph on your calculator and get some better points for those. So that's what happens when we have some transformations. Now in the next video, which you should watch by Tuesday, we're going to see how to factor and identify asymptotes a little bit quicker or a little bit easier without necessarily understanding transformations. But transformations are pretty important to begin with. So hope you enjoyed, and best of luck.